Were you guys able to do that graphing last week? From the first part of the lab?
Yeah.
Okay, so I believe we were talking about SI units. Yes, no, maybe? Yes. Yes. Okay, so the SI unit for mass is kilograms. And kilogram was basically originally defined the weight or the mass of a liter of water. So that's where it originally came from. So now there's a specialized platinum uridium alloy that is exactly a kilogram. That's kept in France, and that's going to be used to define 1 kilogram. 1 kilogram is also 2.2 pounds. We kind of talked about that earlier. Remember we talked about my Tinder activities, right? Like that. They weigh 100 pounds. 100. You guys remember that? Okay, so this is that. That's a replica of the original 1 kilogram weight in France. The SI units for temperature is Kelvin. Okay. You guys remember what Kelvin is for? Kelvin?
An absolute zero?
Absolute zero. Yes. So the Kelvin scale is for absolute zero. In the US, we also have Rankine is for converting from Fahrenheit to an absolute zero, the Rankine scale. If you're an engineer in the US, you typically want to know that as well, because occasionally you will still use it. Understand why? It's okay. Anyway, so with Kelvin, you don't use the degree symbol like we use degree Celsius or degree Fahrenheit. You don't use that. Okay. Also, still a lot of places will still use Celsius. Okay. And so even though the SI unit is Kelvin, most places use Celsius, and then you also get that in science as well, particularly biology. Okay. Questions? Concerns? Cash? So you guys can see at the bottom of the lecture notes, water freezes at what temperature? Okay, or in Celsius?
0 Celsius.
Okay, water boils at what temperature?
73.15 Kelvin.
Okay, and Celsius? Okay, what is it in Fahrenheit? You guys know off the top of your head? No. Okay, a lot of answers. 140, 150, 2 million, 75. Do me a favor. You guys have your periodic table available. Is it pulled out? It always be pulled out for the class. So if you go to the third page at the top right-hand corner, there should be something about chemicals. I mean, not chemicals, temperatures. Short.
No, for me.
Oh, for you. Maybe. Did we have one more of the numbers we handouts? Yeah. Extra. Okay, so if you guys look in that right-hand corner, there are equations that are there. You guys see those equations? One that goes from Celsius to Fahrenheit. So if water boils at 100 degrees Celsius, I want you guys to calculate how much it boils at
200
in Fahrenheit. I got 212. That is correct. How did you know that? It also has that scale up there, right? And it says water boils. You guess. You're full of
It's 9/5 times Celsius plus 32 equals
Fahrenheit. So that's how you would do the conversion. So the equation is actually there located as well. Look down further, right? Now, again, these are things that I don't want you to get hung up on. You can always Google it to be sure, right? So you can also use this packet during your exam. However, when you guys take your other exam, you should know it by that point. So the point is that you have this, you kind of use it under pressure in the beginning, and then eventually you get off of those pressures, right? Thank you. Okay, so the SI unit for time. SI unit for time is seconds. Right? But you guys all know that occasionally we'll use an hour, we'll use a minute, we'll use days, we'll use years, we'll yawn. Right? So often we will use those prefixes that we used before. You guys are familiar with prefixes? Bentham. 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 You guys don't remember Bentham? We didn't talk about that? We did? I'm like, hey, that old.
It's F.
Then, so.
It's F for pitch.
Now, nope. What does that prefix femto mean? 15, 10 to the negative 15. Okay, so 1 femtometer is equal to 10 to the negative 15 meters. You guys remember that? Ooh, sounds like I actually put out a quiz, huh? Oh, he's encouraging it. Okay. So pico. 12, that's right. So that'd be 10 to the negative 12. 1 picometer would be 10 to the negative 12 meters. Or if we want to look at it backwards, 10 to the negative 12 picometers will equal 1. Okay. So we use those prefixes in front of those base units, right? Gram, all those. So you guys remember that, right? Okay. So a lot of times we may end up having to derive SI units. So if we talk about volume, we know that volume represents the space that's being occupied, right? So if I occupy this amount of space, you can calculate the volume that I'm occupying. We look at soda, right? 2-liter bottle of soda. That's 2 liters. That's the space that that soda is occupied. That whole thing of soda, right? If we look at a solid cube, it's that cube that's being occupied. Kind of like what we saw on Monday, professors, Monday, right?
Yes, sir.
Okay, on Monday, we got that cube into the beaker, into the graduated cylinder, and it moved, right? Because it's the whole volume of the cube, right? It's being occupied. Okay, so SI units for volume is cubic meters, but often we will use liters. Right? Liters is more commonly used than cubic meters, right? Because nobody really likes to use that cubic thing. They don't try to avoid most parts. That's the same thing with milliliters. So often in chemistry, we'll use milliliters and liters. Okay, on the volume that we're working. Okay, so 1 deciliter cube is equal to 1 liter. 1 cubic centimeter is equal to 1 milliliter. How many of you guys are planning to be doctors? Nurse practitioners? Yes. Okay. Okay. So for those who are planning that, that's CC. How many of you guys work in a hospital setting? Anybody work in a hospital setting? Okay. Oh. That makes it easy. That's what I'm sorry. That's right. Physical therapy clinic. You as well? Oh, okay. Okay, that explains it all. Okay, so in the case of physical therapies, CC, that term CC. Have you guys, okay, we'll put it another way. Have you guys seen Grey's Anatomy or what is it? Something Hope, Chicago Hope, any hospital show. Okay. And then the doctor says, I need 5 CC staff, right? You guys heard that before, right?
Yeah.
Okay, so what does those CC stand for? Cubic centimeters. It stands for cubic centimeters. So rather than us writing the cm cube, they put cc's. We know that 1 cubic centimeter is equal to how many milliliters? 1 milliliter. So if I need 5 cc stats, how many mils am I going to give that patient? 5, right? Okay. So this is just basically showing you the volume, right? Gives you a perspective of things. Density. Density is mass over volume. You guys calculated density. How was that calculation of density going yesterday? Was it good? Were you on point? You're like, yeah, especially when it takes that long, right? You're like, oh, I know what it is now, right? Did you guys check the cube? Did you check the back of the cube and it had a number on the back of it? Was that number the density, right? It should have been the density of that metal. Did it hold up, or did they give me a bill of goods and sell me the cheap stuff and give me an alloy instead of a complete metal? Yes, measured it. Was it on? Was it on point?
Yeah.
Was yours on point?
I did that part.
Yeah, you were gone. But you didn't talk to your classmates? They're not saying
I
anything.
really did it for sure though.
We did it right.
After we had to fix it, right? We fixed the problem, right? So after it was fixed, was the metal the correct metal?
Yes.
Yes.
I don't know why I'm being singled out. I have 2 other people in my group too.
Well, because I'm looking right at you, right? What about you guys over here? Half you guys left. Speaking of that, where's the other?
The hungry one.
The hungry one, yeah. Where's the hungry one? Right.
Wow.
So what did you guys determine?
Yes.
Yes?
It was on. I stayed.
It was on? Okay, so they didn't sit on me a bill of goods, so it was right. That better be good, because some of those pieces of metals were not cheap. I was a little upset when I had paid. I paid out of pocket too, so I was really upset, right? So the school wasn't paying for it at that point. So anyway, we know that density is mass over volume, right? And so we always know that we look at the units. If it's grams over cubic centimeters, we know that's the density, right? So we can use those units to help us determine what we're looking at as well, too, right? So it's really important to keep those units, right? Okay, so let's talk about, I'm sorry, this is my best topic. We actually talked about it yesterday. We talked about it quite a bit. Remember my weight,
Yeah.
220. Yeah, that's right, 220. Regardless, it's 220, right? Yeah. So that is an example of us taking data, collecting data, having multiple data points that we measure the same thing. So typically in science, there is a rule, particularly in biology, also in chemistry. If you do an experiment, you want to do it in triplicates. Why do you think you want to do it in triplicates? In case there's an error, right? And it also allows us to look at your data points, right? So if one was 220, one was 225, and the other one was 220, then you feel confident about 220, right?
Yeah.
So triplicate is a nice number. I mean, ideally, if you have money, you could like this, because it really depends on money. If you had money, you would do it like 10 times or 20 times, right? But if you don't have money, you do triplicate. Triplicate gives you enough confidence that it's going to be accurate. Now, if I had 210, 110, and 15, would you believe that data?
No.
No, because it's all over the place, right? So there's a lot of uncertainty involved in that. So as a scientist, you'd say, you try us back in there and do it again, right? If you're the boss, right? You guys are all planning to be the boss, right?
Yeah.
That's what I would assume, okay? Hey, better do that again. That data is crazy, right? Because you want it to sit there and be more precise, right? Doesn't necessarily have to be accurate, but you want that precision. We've talked about precision and accuracy. We're looking at that. Precision and accuracy.
Precision is like how close you are to it, like how many times you can bullseye, and then accuracy is like here.
Sure. Should we have that switched? Don't put money on it? You got $5? Come on, you gotta come to class with money, right? Because I'm a gambler. You guys are gamblers?
Yes.
No. Oh, you guys are no fun. I love gamblers. I love gamblers because I earn a little bit of money at the end of the day, right? So, precision, accuracy. Does anybody want to help them out? I'm not saying that you're wrong, but I want to see if anybody want to help them out. You want to help them out?
Yeah, accuracy is how close you are to your actual number that you're aiming for, whereas precision is how close are your numbers that you shot out are close to each other.
That is correct. So you have part of it right. It was that closeness together, right? And so what are you saying? That precision is when those numbers are really close together, that's precise, right? Accuracy is hitting exactly what you want. Okay, so in science, we do a lot more precision than accuracy. Because let me tell you, I learned that in science, about 65% of the time you're wrong, and about that 35% of the time you're right. And you got to get used to it. That's the way science works. So don't go home and cry about it, right? I did it for that first week. I cried that first week. And then I noticed the same thing was happening. So I was like, I'm not crying the next week. And the next week after that fixed me real quick. Because otherwise you'd be crying for years, right? So science is one of those hard, they break your heart, right? You're thinking something, this is definitely what it's going to be, right? I'm going to be accurate on this, right? And no, instead you're precise. Right? And so you'll find that out over time. So that's kind of like, let's see, how many of you guys have fitness goals? I knew I would get one. Right?
You're gonna get me.
Carries a bottle of water every day. He says, nope, we got to use stevia, right? Okay, so I do it. Okay, so you have fitness goals. How accurate to your fitness goals are you? Are you dead on?
No, more or less, I would say.
More or less?
Yeah,
Or would
close.
you say you're more precise?
I'll say precise.
You'll say more precise. Okay, how many of you guys have goals? Anybody have, do you have goals?
Yeah.
Okay, are you precise with your goals?
Yes.
Are you more accurate with your goals?
More precise.
More precise. Okay, what about your grades? You guys grades, right?
Yeah.
Well, the goal is A, right? Everybody's goal is an A. How many of you guys have a 4.0 right now? I want to know. Got 1, 2, 3, 4, 5-ish, right? You got 5 that have a 4.0 right now. Good, I like that. That's good. So you guys, are you accurate or are you precise? Or both?
Accurate and precise.
Accurate and precise. Okay, so there's no uncertainty about that, right? Because that is a 4.0, it's not a 3.95, is it? It is a 4.0?
Yeah.
Or a 3.92, right? Okay, no uncertainty involved in it? Will chemistry add an uncertainty to it? Hopefully not. That's exactly what I want to hear. Hopefully not, right? So the goal is to get an A in this class, right? So you can keep that 4.0, right? Okay, good. So, but let's say you don't get that A, right? You get that B. So does that a little bit uncertainty? Let's say the bulk of the semester, there's that uncertainty going through. You get that last week, and you're at that B grade, you know, you're at that 89.2, right? Right? So would that be a little uncertainty?
Yeah.
Right? And if we rely on that, okay. So we know what uncertainty is, right? You're all aware of it. So we have uncertainty in every aspect of life, particularly when we're doing types of measurements. And so we have to account for that uncertainty, right? The way that we account for that uncertainty is typically by adding plus or minus, right? Plus or minus something, right? You'll see that occasionally. We don't really use that much anymore, right? We use what we call significant figures. Okay, you guys are ready for significant figures? Okay, we're gonna go to the board on that. I hate my slides on it because I like examples, right? Works better for me. So let's talk about sig figs. See, I remembered this time. Gonna get this. I go. See, I have holes.
You have fitness goals too?
I do have fitness goals for this term, yes.
I like.
My first fitness goal is to drink enough water. I'm horrible about drinking water.
And
I used to have a student, Dr. Harry, watch your squat.
That's clutch.
As you can see, you know, I've been better, I've been bringing it myself, you know, because that student graduated, because they had their soul card, and you can see like the crust developing on the side.
It's initiative.
Yeah, so that's why my major one, because it always kind of starts with water. Water is life, right? You just understand that, right? So, you know, you need to bathe, you need to drink, you need to make sure that you're hydrated, otherwise you can't lose the weight, you're not healthy.
Yeah,
Your
it's not
teeth are not all green and stuff like that. It shouldn't be green, but you know. So anyway, let's talk about sig figs. Now, when we talk about sig figs, there's a couple rules that I want you guys to keep in mind. Okay, so 101, like Chem 101. So in this case, if we have a 0 between two numbers, right? All three numbers are going to be considered significant. So when we look at significance, we're looking at where those zeros are going to be at. Okay, so for instance, right now this is 101. So all numbers are significant. So we have three significant figures, right? If we have 1, 0, 0, 100, right? We have one number that's significant. This number, we know that's a 1. Why do we know that's a 1?
In front of the zeros.
Because it's a 1, right? It's a number. These zeros, we don't know anything about, right? So really, this could really, in all honesty, be, real honesty, it could be 98. It could be 103. It could be 101, right? Because nobody was significant about it. They didn't put a decimal point here to say, I really mean that this is a 0, right? Because it takes a little extra to put that decimal point there. You guys understand, right? So by them putting that decimal point there, it changes from being one significant figure to three significant figures, right? And if they take that extra time to put a 0 behind that decimal, that's four significant figures, because they're saying, you know what? I'm so good. I know that I put this decimal point here and I put another space. I know that number is a 0. I'm not questioning it. I know what it is. Right? So you guys can understand. Okay? So if I have a number like this, these are considered space holders, right? They're just letting us know that we have a very, 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 very small number, right? But these zeros in front here are not significant. Okay. Only thing that's going to be significant are these numbers here, right? If I follow with another 0, because it takes extra to give me that other 0, that means it's going to be significant. So if I put a 0 here, these three are going to be significant. Where these are just holding space. Okay. Now, the most commonly made mistake with students and significant figures is when I say this guy is one significant figure, right? And I say, so what is the answer to this problem according to the number of sig figs you have, right? A student will tell me this is 1. Right? Now, if I ask you how many sig figs there are, the answer would be 1. But if I ask you what the answer is, it's 10,000. Right? Okay. So let me give you another example. I'm going to put a number up here, and I want you guys to write it so that there's two significant figures. Now, here's the rules. You got to understand the rules before you do it. If the number is greater than 5, example. Okay, we want two sig figs for this number. We're going to look at this 5. Number is greater than 5, we're going to round up. If the number is exactly at 5, meaning there's no other numbers behind it, it's exactly at 5, we're going to leave it alone. So we'll just take those two numbers, put zeros there. And then if the number is less than 5, we're just gonna leave it alone and put zeros there. Okay, so right now, 5 is our teeter point, right? And the way I like to look at it is, if it's at 5 exactly, it's perfectly balanced. Have you guys ever played seesaw with somebody? Somebody sits on one side, the other, okay, up, down, up, down. If you guys weigh exactly the same, it's gonna be perfectly balanced. If you're a little bit more, it pushes it up. Right? If they're a little bit more, it pushes it down, right? Okay. So 5 is our reflection. If it's greater than 5, we round up. If it's less than 5, we round up. Okay. So this guy, is it greater than 5? Is there a number following it? So would that be greater than 5, or would that be less than 5? So there's a number following it. Okay. We're looking at this number. This is we want 2 sig figs. Now look at this number. Is there a number more? Does this make it? Is it greater than 50? Like that. Is this greater? Is 51 greater than 50?
Yes.
Right? Because we're using this number to determine whether we're going to round this one up or round it down. Okay? Since this is a 5 and there's numbers following it, it's greater than 50. It would be easy if this was like 1, 2, 7, right? We don't want to use it, right? And we're using this number to determine. Okay? So we all know that this is going to be rounded up. So we write this as 1,300, right? If it's 5, it's exactly 5, right? Then you look at that next number. If that number is not a 0, then you're going to round up. Okay? If it's 12, 5, 0, and we're using this number to determine whether we round up or round down, it's exactly 5. What's that?
How's that?
We're going to leave it as. So we're going to round down, right? If it's 12, 3, 0, we're still using this number here. Let's say I want 2 sig figs, right? Okay, so we're going to make this. Okay, you guys see that, right?
Yeah.
Who doesn't see that? Raise your hand. Okay, good. So let's see. Okay, the goal is we want 3 sig figs. 3 numbers up there. 4 numbers. Okay, and I want you guys on your piece of paper, write down the answer. Okay, again, we want 3 significant figs.
Dr. Henry, that first one is 3 million.
This one here?
Yeah.
That's 3,279,000. Goal is to get 3 significant figures. You guys are there. Don't overthink it. mass. It's 5.9. So everybody got an answer? Anybody not got an answer? Okay, so if we're getting three significant figures, the first thing is that we want three numbers, right? 1, 2, 3. Okay, so that means we're going to go here. So that means that we're looking at this number to determine whether we're going to round up or whether we're going to leave the first three numbers alone. Okay, so is 9 greater than 5 or is it less than 5? It's greater than 5. So then the answer should be 3, 2, 8, 0, 0, 0, 0. Okay, again, three significant figures. Okay. So if I'm looking at this number, if I'm counting the number of significant figures, where am I going to go? Where am I going to? Who's going to be my determinant? The 2 is?
No. Zero.
This 0 is going to be the determiner. So I'm going to look at the 0 and decide whether I'm going to round up or move up. I'm going to look at the one next to it, the 1. The 1 is going to be the one because this is three significant figures right here. So we look at this one. And then what did you guys decide?
Round down.
To round down. So then the answer should be 0.0000720. Okay, and we know that this 0 is significant because we took that extra time to put it, right? We're lazy, right? And so you don't put any extra time unless it's important, right? Is that true? It has to be important, right? You're not going to get out of bed unless you're at class, right? So, okay, now if we look at this one here, where's my line? Which number am I going to use to determine whether I'm rounding up or rounding down? The 5. Okay, so am I going to round up or am I going to leave alone? Okay, so my answer should be 3, 0, 3, 0, 0, 0, 0, 0. You everybody get that?
Yeah.
Okay. So now let's see if we can be sure about those sig figs. You guys understand what I'm talking about? Sometimes it's a little hazy. Everybody got this down? So okay, so determine the number of significant figures for A, B, C, D, and E. Volunteers for A?
You got a 4.
We got 4. So I'm assuming right here. 1, 2, 3, 4. Okay. What about B? 7. Sure.
So,
8. Yes. 1, 2, 3, 4, 5, 6, 7, 8. All of them are significant. Okay, because we took that time to put that decimal there and those zeros, right? If it wasn't important, we wouldn't do it. Yes,
So if there's like a third number after there would be 9 then.
that's right.
Okay.
but then if it was like an infinite number of zeros, then there'd be an infinite number of sig figs.
Yes,
All right,
yes. Painfully as it is, yes, it would be. Yes.
I had to clarify.
Okay.
Oh, wait,
This one is all of these. This one is.
Yeah, 3.
3?
Don't put money on it?
Oh.
Fine, okay.
That's-
Okay, remember, if I took the extra time to put those zeros at the end, right? Right? So it's a total of 5. Two. Because we know that these zeros are just holding that space. And 5, that is correct. Why? How did I put that decimal, right? Okay, do you guys see that? Good. Ready to move forward? Next part. Okay, so the next part is operations. So we're going to do addition and subtraction. Okay, so when we do addition and subtraction, what we have to do is kind of have to line up. Right? So if I have 0, 0, 1, I'm adding 3.1 and 12. Okay, so how many sig figs do I have in the first? So the last number of significance is squared.
1.
1. Okay. So I will draw. Okay. And the second number
0.
is 2 symmetric figures. So where would I draw the line of significance? After the 1. Okay. The 12. 2 significant figures. Where would I draw the significance? After the 2. Okay, so let's go ahead and add them up. So we have 1, 0, 1, 4. Okay. So the one that has the least number of significance is that blue, right? It's not the least number of significance, but has the significance to the closer to that number is the blue. So then what we're going to do, we're going to take the number right after that to determine whether we're going to round up or round up. So since this guy is a 1, what are we going to do? Let's see, round down. So it's going to be
4.
You guys see that? Okay, so let's try another one. Let's say we have,
Hey, Dr. Henry, if the equation has a decimal in it, in your answer, do you have to have a decimal in it as well with 0 or?
No, in this case, you wouldn't because it would still be three significant figures. You
Oh.
could put a decimal there, it would still be three significant figures.
Can you repeat why would be the one that will determine the?
Yeah, I can.
Yeah.
So what we do is, so you want to go over to the closest to those numbers, right? So that you can go, and then that's going to be your number that determines, the number after that's going to be the number that determines significance. So like, for instance, this guy is in the 10th, the one spot. This guy is in the 10th spot, right? So this guy is more accurate than this guy. This guy is less accurate. So we have to go to the one that has the least amount of accuracy. So,
Why
makes
would
sense.
you choose the one in the last one?
What was that?
Why would you choose the one in the last one?
The one here?
Not the one.
The one here,
Yeah.
right? Because this one is more accurate. Because we have more decimal places to it, right? So they actually are really good. They know that this one is right, that value is right. They know that this value is right, but this one, right? They may be a little bit unsecure about. But this is the last point of insecurity, which is in this is the 10th, this is the 100th, this is the 1,000th spot, right? So this guy is better. Let's say if we're looking at scales, right? If we're looking at scales, this guy is more accurate than this one, right? This one only goes to the ones place, right? So it has less accuracy associated with it. So when you're looking at it, it's the one that has the least accuracy that's going to dictate it. Because you don't know if this is 11.9999 or is it 12.2 or 12.8. You don't know. You just know it's close to 12, right? So it can be a little bit less or it can be a little bit more. We don't know, right? Where this one, we know what's right after that. That's a 0 after that, right? And we know what's right after this. So this one is the one that gives us the most uncertainty. So you have to use that. Does that make sense? Question? Thank you for stopping. You guys had that look, that sour look on your face.
Yeah, I feel like
It's a little troubling. It's like this, right? So you have your rich people and you have your poor, right? No,
I feel like it would
that's
be
what
easier.
it was down
It'd be
to, right?
easier,
Because if
though.
we're all the same, right? If we're all the same everywhere, we wouldn't have this issue. But the problem is that you have your rich people and your poor people, right? The poor people have a shitty scale, right? So they can only see two numbers. Have you seen those scales? I had this really old scale that my mom had, right? It would only, the first two numbers you could see. So it would be like 140, right? And so you couldn't see that third number, right? It would have a number there, but it put 0 there all the time because it could tell the difference. So you'd always have 140, and then that would always be a 0 at the end, right? So you wouldn't know if it's really 140 or if it's 145 or if it's 149 because it would just say 140. Right? And then, so that's an example of a really cheap scale. Where we have scales today that will give you 140.723, right? So we can go out 3 numbers past the decimal, right? So that one is going to give you more accuracy to what you really weigh, where that 140 is just going to say, well, it's just 140, right? So you may be 147.29, but the other scale only says 140, regardless. That's the best you're going to get, right? So because that other scale is so crappy, you have to account for that other scale because that's the one that's going to give you the most uncertainty. That's the one you don't know the most about. The other ones are more precise, right? Or more accurate, not precise, accurate. So easy to use that word. Okay, so let's see if I kind of cleared that up. No problem. guys ready to work through it? It's got it. Okay, that first number, where is the last digit of significance? Okay, the next number, where's the last digit of significance? 4. Okay, and the last number, where is the last number of significance? The 1. Okay, so let's go ahead and add it up. Okay, what number am I going to use to determine whether I round up or leave it alone?
5.
Okay, should I round up or should I leave it alone?
Round up.
Round up. My answer should be fine.
There's no standard.
We don't put the zeros because. Okay, okay, so yes,
In regards to the rule with the number 5, when it stays the same, is that in a different situation?
if this was all zeros down here, that would be,
No, if it was 5,
what was that?
if it was 5, is that only when the number in front of it's 5, then it would remain the same?
No, so this number was 5, right? Our determining number was 5. These were all zeros, then it would stay the same. Right? But that's, it's kind of like, it's barely a difference, but it is pushing it up, right? Because it's greater than 5, right? So it's slightly greater than 5, but it's greater than 5, right? It's kind of like it's 5 points, in this case, it's like 5.3, right? So that's greater than 5. It's-
Oh, I see what you mean. Not the number 5 itself on the second value. but-
That's right.
Yeah, that.
Yeah, because there's numbers here that makes it slightly greater than 5. Not quite 6, but slightly greater. Okay, so then how many sig figs do I have? 2 sig figs, how many sig figs do this one? 3. Okay, do you guys see that? You see how to do it with addition? Well, addition and subtraction. Subtraction works exactly the same way. Do an example here for subtraction. It just takes a lot more thinking, you know, addition is a lot easier. Okay, you guys ready? I can erase this first one. Okay, you guys ready? Okay, so what is the last number of significance for that first number?
0.
Which 0?
The last 0.
Okay. What is the last number of significance for the second?
That's it.
Okay, so let's go ahead and subtract it. Okay, so what is going to be my answer?
13.
13 or 13?
13.
13.
It's going to be 13. Right. Because you take this number, this is the number since there's this line here, right? Use that front line. You take the number after that front line and you determine whether you're gonna round up or move on. Right? So this is 0. Am I gonna round up or move on? Right? No, am I gonna move on? Move on. So that's how I ended up with 13. You guys see that? So, you'll see
Say
that?
it one more time?
Sure. So, I use the front line, that very first line, and then I take the number after that. This number is 0. So that's 5, right? I'm gonna leave this number alone, right? And then that you just drop off. Because this here, so this here is only search the first one place, right? So that means that the best I can do is have a number of one place. If I have a decimal there, you're saying that it's more certain. Really, this could be actually 8, it could be 7.99. We don't know. Their scale can only be up to 7. That's all you can see. So it could really be 7.99, or it could also be 6.9. So we're uncertain, we don't know. There's so much uncertainty. Does that make sense?
Because doesn't go like with the allowance of life, so it goes down. So we
That's-
take off that.
That's right. So let's say, for instance, if this was, we're gonna change the equation here. Put a 8. Okay, so if we do the math here, that's gonna have an 8, right? So then again, this determines. So in this case, what was the answer?
14.
Again, how do we say fix? Say fix.
Patrick, I thought you would look at the one with least accuracy. Wouldn't
Yes.
that be the 7 though?
We did. 7 is the one that has the most accuracy, right?
Oh, okay. I thought you would look at the one spot still since I
Yeah,
was one.
well, the one spot, right? But you're using that one. Since this guy has the least accuracy, you have to take the number that's here, decide whether we round it up. Because this guy, it has a number. In this case, it has an 8. So we know that that's number is an 8. We're sure about that number, right? We're saying close to sure about it, right? It's gonna be close to 8. Right? But here we don't know what this is, right? So this could be 7.3, right? So if it's 7.3, then that would give us that 14, 7.2, give us that 14, right? So regardless of what the number is here, we know that it's gonna be closer to 14 than to 13.
There's a
because
number
there's
there.
an 8 there.
Oh, okay.
Does that make sense?
Yeah, that makes sense.
Was that? Another? Sure.
Practice for sure.
Yeah, you guys talk about this again. I have to tell you, every instructor hates teaching city pigs, but until you really use them, you know, it's all like a big blur. So you have to work with hundreds of sets of data, and then you look at us, oh shit, I'm getting stuff from New Zealand, stuff from Africa, and then you realize, oh crap, they don't have the same crap as these calculations. And so making a difference, and you're like, okay, I get it now.
Yeah.
That's right. Okay, so we're gonna draw that first line.
After 2.
About the second.
After the 2.
After the two. Let's go ahead and do the math. Okay, so what number am I gonna use to determine whether I'm rounding up?
Seven.
So, are we rounding up? Are we moving along?
Rounding up.
Okay, so my answer should be,
Two.
how many say faces is this?
Two.
Piece of cake?
Yeah.
Now, it takes a bit, right? Like I said, at first, it's not an intuitive thing, right? You don't, it's kind of like, it's like planning ahead, right? None of us want to plan ahead, right? We just want to do it, right? And this is kind of like planning ahead. Yes.
Would it change with divisions?
Yes, good question. You're ready for the next part. Yes. Good question. Multiplication and division. So when you're doing multiplication and division, you have to pay attention to the number of significant figures that each of them have. So let me give you an example. Okay, so how many sig figs does this one have?
Four.
That's 4 sig figs. How many sig figs does this have?
4.
4. And then how many sig figs does this have? That's 2. So the one that has the least amount of sig figs is the sig figs we're going to end up with. Okay, so multiply this. Okay, so how many sig figs were released?
2.
So then we take the one that has the least amount of sig figs. So 25. So we want an answer that has 2 sig figs.
So you
Yes.
basically do the calculations like the same way, you just multiply everything and at the end, you just gonna determine the safe fix. right?
That is correct, yes. Yes. Okay. So you guys see that, right?
Yeah.
Not too bad, not too bad. Okay, same thing with division, right? So if I have okay, how many sig figs do I have for the first one?
3.
How many sig figs do I have for the next one?
1.
So my answer is going to be, okay, so then how many sig figs should I have?
1.
I should have 1. So my answer is 1. Okay, least number of significant figures. That's it, piece of cake. Okay, so it gets a little complicated when you guys have multiple operations going on at once. Do you guys PIMDAS, something like that?
I've
I don't
done
remember what it's called.
Please excuse my dear Aunt Sally.
Tim Knox, please excuse my dear Aunt Sally. Yes, okay. So you're gonna use that as well for this as well. So you want to do your parentheses, you want to get your sig figs, right? Then you want to do whatever the addition. Okay, so let me give you an example because it's easier to say it visually. Everybody get this so far, right? Good. I can erase. I need acknowledgement, right?
Yeah.
I'm sensitive. You know, you want to make me feel good about myself. So, all right, yes, good. Okay, so let's say we had So our first instinct when we're doing safe phase is to do the math and do the division, right? But you can't do it that way. Right? So you need to find out your answer for the safe phase here. Then you're going to divide it by. Okay? So let's do our answer. Let's say phase here. So I have 2730 plus 0.7551. Okay? So that first number, the number of significance in squared. After the first number?
0.
After the 0. Okay. I know, I did that initially. First instinct, right?
Yeah.
Okay, so then the second number, significant in square. Okay, so we'll do the math. Okay, so what number am I going to use to determine whether I'm the first 5 or the second?
Second five.
Second one.
Okay, so my answer should be okay. So then I'm going to divide that by 2 and 2.1. So I did the hard math.
I got 13.4.
13.4. Anything afterwards?
Oh, that's with the, already did the 6 big one.
Are you sure? Sure you did it right? Put money on it.
Down.
Okay, put your money on the table. Whatever. Come on. Everybody heard it. Sit down. Put money on the table.
Yeah, we did 13.36.
So what do we do? 13 point what?
36.
36. Okay, so this has how many sig figs? There's 4 sig figs. This has how many sig figs? 2. So how many sig figs do I end up with? 2. So my answer should be where's my money? Come on, pay up, right? See, that's what that jar is for. Everybody say tip jar? No, it's a tip jar. The tip is put your money where your mouth is, right? Okay, so do you guys get that?
Yeah.
Does that make sense? Yes. Right. So that's sig figs, you know, and it's sometimes it don't make much of a difference. Sometimes it's the world of difference. We were sitting there doing a study. I had, it was painful. I think we had over 10,000 patients. We had some that were coming in from Zimbabwe, from Kenya, from I can't remember, the Congo. And then we had patients that were from the States. And then we had patients that were from Switzerland. And we were just collecting all of this data. And literally you can tell the difference between the precisions of some of the data points, right? Some of them, 5 decimal points out, and then others you get, maybe 1 decimal point to the left, right? And so you're like, okay, so for us to be as accurate as we can be about it, we have to take into account that one that's the least accurate. I'm trying to do this with massive amounts of data, right? And initially I was a newbie and I started trying to do this by hand. I'm like, what the fuck is it? I cannot do this, right? So then what I ended up doing, I wrote a program that would actually go through, analyze the data, and then determine the number of sig figs that we should get out of it. And so if you look at the data compared to when you look at the significance, it was huge, right? If I had used the original data, it was crazy. So we actually did a study, and it was basically based upon drug resistance, right? So the idea is that if we give a certain amount of a certain drug, it should prevent that drug resistance occurring, right? And based upon that data, right, if we had used the original data, the patients would end up studying a couple of places. One was using less amount of drug, one was using the one that we actually calculated based upon the data. And so we had clearly a distinction, right? Then so what we did, we switched around just to make sure we had a population issue, right? So we used the same drug, different concentrations, different population at the same place that it was initially, where we saw a lot of drug resistance happening after we had done those calculations, right? It prevented that drug resistance. And so just by taking into account that uncertainty could be the difference between somebody's life or death, right? So often you guys, if you see those ranges when you get your labs back, right? Those ranges are based upon uncertainty. So that's why it's important. Okay, let's move forward. You know, I get a lot of walking done throughout the day. Kathleen, can you hear us? Thumbs up if you can. Move forward. Okay, so this is just basically showing you some of that uncertainty, right? So we all took a look at this graduated cylinder, right? And we know that when we're taking measurements and we're looking at volumes, we're going to use that meniscus, right? So we draw that line at the meniscus and we will go across, right? But we know that this guy is between 20 and let's see, 21, right? So it's between 20 and 21. So is that closer to 21 or is that closer to 20, right? We have that uncertainty. So we know that it's anywhere between 22 and 21. So this is 1, 22, sorry, 22 or 21. Okay. And so because that meniscus is anywhere between 21 and 22. So is it closer to 21 or is it closer to 22? Right? If we go across the room, take a survey. Oh, no, I think it's closer to 21, right? No, I think it's closer to 22. But we can agree that there's some uncertainty involved in it, right? So, but we're not sure about that. That's kind of like, have you guys used our scales? Did they fluctuate or did they use just a perfect answer? Did they stay stable the whole time? It fluctuates. That last number fluctuates, right? Last couple of numbers in some cases, right? And so that is that uncertainty, okay? So we take an estimate, right? Because that's the best we can do. Well, it looked around 0.6, right? But that's uncertain, right? So that's the reason why we have to use those sig figs, because somebody looked at it and says, oh, you know, you guys took those measurements, right? Were they certain? Right, you guys, and you're like, okay, I got to take a guess, right? Because it was fluctuating, right? So you take that estimate, right? Oh, it looks like it's closer to this, right? When you wrote it down, you're like, hey, it spent more time here than it spent over there, right? That's not how you guys did it?
Yeah.
Okay. So that's why we use sig figs. Okay. This is just telling you about sig figs. It's more descriptive than my beautiful handwriting. It's the same thing that we just did. Okay. So it tells you the definition of leading zeros and trailing zeros and captive zeros. Captive means it's between two non-zero numbers. Trailing zeros means that there's zeros following it. Leading zeros, these are leading zeros. So we know those leading zeros are just going to be space holders, right? Trailing zeros, if there's a decimal point, in this case, decimal point here, we know that trailing zero becomes significant, right? Because it takes an extra. So we talked about how to use it for fractions. If it's greater than 5, it's less than 5. If it's right at 5 perfectly, that was this case down here, right at 5 perfectly. Perfectly at 5, there's no numbers after it, so we 92.8. And it's funny because when we're in high school, you guys remember in high school when they told you It's great if you round up, right? That's the rule. Right. Well, you know, that really isn't the rule in that. So. Okay, we've talked about accuracy and precision. This one is accurate and precise. This one is precise, but not accurate. This one is neither, right? So, looking at the data here. All right, so it's supposed to be here. It's supposed to pop up after. Pretend that it isn't here. Look at the data. Which one is accurate? What is the first one? Spencer one. Is it accurate or it's precise? So we're trying to get 296. That's our goal, right? So it's precise, right? Because the data points are all close together. What about the next one? Is it accurate or precise? It's more accurate because it's still kind of fluctuating, but it's more accurate. What's that value that we want? What about the last one? It's both, right? Gotta fix my slides. Okay, so the next thing that we want to talk about is dimensional analysis. You guys already done it. You guys are ahead of the game. You guys did dimensional analysis, yeah, last week. We're just so far ahead of the game. Okay, so you already know about conversion factors, right? We've talked about conversion factors. So 2.54 centimeters over an inch, right? And then, so we know that we could use it either way. So these are some of the most common conversions that you guys will be using. This guy is exact. I should talk to you guys about exact. When you have a number that is exact, you don't worry about its significant figures. Also, when you're looking at conversion factors, you don't worry about sig figs, right? So when you're doing the calculations, you don't have to worry about those for sig figs. You're going to look at the number that's given to you in that cases if you're using conversion factors. Does that make sense? That's right. That's right. Yeah. So if you're given two numbers that you have to work with, then you worry about sig figs, but you don't use the conversion factors to determine your significance. You also don't use your periodic table because your periodic table, if you take a look at our periodic table and you compare it to somebody else's periodic table, right? It's going to be different because they've rounded in different places. So you never use that in terms of your significance. Okay. Questions? No, because that periodic table is going to be a little bit different than the periodic table that you would use for, like, that comes from the army, right? Because the person that made those periodic tables, they ground. Okay, so if we go through canceling out, inches is the old bow, so it's no longer a priority, so it's going to be at the bottom. Centimeters is the new bow, so we're going to end up like that. Okay. Temperature. We've already talked about temperature. You guys already did the conversion. Not much to say. You guys already know this. We already talked about it. We're so good. We've talked about the Kelvin scale, right? You guys are on fire. El fuego. Right? This is the calculations to do those conversions. You want to know it. You want to be able to calculate it. I always use that zero reference because I always get mixed up with the equation all the time. But I use the zero reference because I know that if it's 0 degrees Celsius, I know this is going to be 273.15 Kelvin. So I know I'm just adding 273.15 to whatever it is in Celsius. When I'm converting from Fahrenheit to Celsius, I also use 0 degrees Celsius because I know that it's going to equal 32, right? And then if it's boiling, right, I know it should be, for Fahrenheit, it's 212. I know that from the top of my head, so then I know I can work back to that equation just in case, right? So I usually check it out just in case because I'm good at flipping things around. So these are your different temperature scales. You guys have already seen it. You also see it on your handout, right? The little figures, not as pretty as those nice little thermometers, but it shows you exactly the same thing. What we were just talking about, 32 degrees Fahrenheit, 0 degrees Celsius, 273.15 Kelvin. If water boils at 212 degrees Fahrenheit, which is 100 degrees Celsius, and 373.15 Kelvin. No, not fine. Break time. Okay, so let's take a 5-minute break and then you guys have your hands out for labs. I need to go in the back room to get your chemicals. Right? So, give you that. And next week, it's gonna be a little bit different. I said, Thursdays. Next week, you guys are gonna be doing a wet lab on Monday. Okay, so remember your gear, your shoes, you already have your lab coats, your goggles are over there, right? We're good there. Okay, if you don't, we have to get you fitted for a lab. Is that correct?
Yes, but I also have like another question.
Yes.
You sure about next Monday?
Oh, wait. Thank you.
Because
I was definitely.
Because I was gonna ask if you could send me.
No, you guys need to be here. You gotta be here. No. Next Monday is a holiday. Is that correct?
Yeah.
Oh,
I can't pull up on this fast though, honestly.
I forgot too. So I knew there was a reason that I initially had it in my head that it was gonna be, we were taking that turn, but I totally forgot about Monday being a holiday. Okay. Well, guess what? You guys don't have to worry about it on Monday. You don't have to be here. Just on Wednesday, so it does work out. So Wednesday, bring your gear, right? So thank you for reminding me. And she was like, I had a question. I thought. Okay, so it's gonna be your first lap. So what I'm gonna do is I'm gonna print it out here in a minute so that you guys get it today, so you guys can have an opportunity. You'll have the whole week next week to look over it beforehand, right? So you want to make sure that you understand the chemicals that you're working with, some of the hazards that are going to be associated with. Today's lab is dealing with those hazards. It's talking about those hazards. It's talking about those things that we talked about last week. And last week on Monday. Yes. For today, yes. Yeah, we still are.
Oh, okay.
So everybody did bring their laptop, right? I haven't forgotten, but I'm glad you reminded me. Yeah, so that we can get that graphic done. I also asked if you guys were able to get that graphic done, because you guys would be able to help each other.
I confused what graphic you're talking about, and I like.
Lie to me.
Well, I got the wrong one, so-
So he just admitted.
But he's
lied
honest
to me.
now, though.
At least he's honest. Okay. I'll let it go. I'll let it go this time. Okay, so let's go ahead and take our break because that gives me a chance to go in the chemical room and grab the chemicals that I'm planning to grab. And then you guys can get started. Okay. Everybody has their data available. Okay, so what we're gonna do is we're gonna enter this data. So go to Google, our Google Sheets. So if you actually go to the lab itself, it actually has the data, so you can copy it and paste it into your Google Sheets. Everybody has their Google Sheets open. Or is the lab showing up? Lab receipt?
I said it's locked, and it sounds like the second.
Okay, so let me fix that.
The class is like the section. Very sure what. Oh, yeah, on the tab on the very left side is a crucial. Oh, yeah. That one.
So at the bottom of module one,
Yeah.
you guys should be able to see the lab as it show up. You want to hit refresh. It'll say lab 3 accuracy, precision, and graphic.
Yes.
It is showing. Are you able to, will it open it up now?
It says it's locked until September 2nd.
Oh, okay, that would be a problem.
Yeah.
Yes, or just the.
Okay, right now?
Yeah.
Is it showing up? Is anything showing up?
Yeah,
Okay. It's changed, it doesn't have all my pictures. in it. Right, actually, doesn't have hardly anything, but it does have the data.
I was just wondering if you guys.
So you see where it says table 1?
Send them some.
Yeah. it should.
I just remember, remind me that. Just the images.
I just want to.
Maybe we also update that. I'll do that.
Oh, yeah.
Because we're missing the whole diagram.
Well, you can see it on
What's that?
Want to re-upload the whole thing?
Possibly, you may have to click the image out. Okay, so. Are you guys how you guys doing on?
Yeah,
You doing, yeah?
I need help, like, yeah.
Okay. The data points, those first data points, all I want you to do is the graph.
Oh, I opened up the lab, but I just said no.
Hit refresh. Oh, actually go to Monty's.
Yeah.
Nice.
So in modules.
Just very sheets and then copy.
Yeah, copy that first data table. So it should, your graph should look like a graph that you guys see in your handout, which is not showing up on anything. So if you hit copy and paste, it should. Is that working for you? All in one. Oh, it's different, oh, in one box.
Cover charges.
Guess you just gotta enter. I don't know why it does that. Or try actually putting the same. Highlight the same number of boxes. Out there. Yeah, I do know. Just. I'll have to fix that. I don't know why. Classroom. Go open the door. It happens.
Oh, okay.
There's.
Good nose on you.
Yeah, and it actually could also be some. Yes. Okay, so you want to go to chart. Highlight both columns. Go to chart. Chart will be under insert. So it's the same process that we did before. Yeah. Yeah. Now, only thing now you're gonna make it a line graph, right? So I already did that scatter plot for you, scatter chart. That's good. Oh, that's fine. Okay, so we want actually go back to scatter step. Okay, so we have that scatter plot. So what we want to do, we want to fit that line, right? After you guys do it, everybody has it entered. So anybody not have it entered? It's not allowing you to copy or anything. So after you have it entered, you're gonna highlight, gonna insert, you're gonna go down the chart. Okay, it's gonna automatically say, okay, you have this data. Now you'll notice the X is already in the X, the Y is already in the Y. Okay, so we want to so you want to go to your edit window. It's been a while now. So if you go under customize, under series. You can allow it to enter error bars. So these error bars are based upon percentages. You can have it label your data points. And then you can add a trend line. So that trend line fits the curve. Okay, so if you take a look at my trend line, I also have it showing. I have it showing the R value. The R value lets me know how close to my curve I actually am, right? So the closer that R squared value is to 1, the better it fits your curve. So I also want to know if there's an equation, right? So if I go to custom, I go equation. So now it actually shows me the equation and it shows me that R value. So my equation is now 9.91 times X plus 1.69. That R squared value just lets me know how well it fits the curve. Okay. Questions? Concerns?
How'd you get the line? I missed that step.
So if I go to customize, right? I go down to series. I open up the series, I scroll down it, and then it says trend line. I select trend line.
Yes.
I want it to be a linear curve, so this gives me the option of different types of curves, right? And if I hit that trend line, it'll actually graph it.
Good.
And then I want to go to label, and then I want to go down to use equation, and I also want to show my R value, R squared value. Okay, you got it?
Yeah, I got that.
Piece of cake, not too bad. Okay, so that's the first set of data, right? It's a linear curve, it looks beautiful. Sometimes you've got to try to fit. So do me a favor, let's say, let's just use a different form. So instead of hitting linear, go to exponential, right? If you look at that exponential and you look at your R value, although they're pretty close. But my linear has a larger R value, right? So my linear is 0.976, where my exponential is 0.972, right? So my linear fits better. So sometimes if we're looking at, let's say, a rate of a reaction, we may need to sit there and take a look at those R values and try to find the one that fits better, okay? Maybe it might be an exponential reaction rate, or it could be a polynomial reaction rate. Okay. Or it could be logarithmic or power series. So, but in this case, we just wanted you to do a linear one, but it does give you that flexibility. Okay. Questions? Okay. So you guys ready to try the next one? A real one? Okay, so it's the data in table 2, I believe. Second table, the flow rate. That one, take that data. Did it show up on your?
Yeah, sure. Going on a different sheet.
Yeah, let's do it on a different sheet. It keeps everything a little, yeah. So otherwise, I'd have things going in all over places. So if I wanted to make sure that my points fit into my screen, what do I need to do?
So type of center one.
Okay, so if I go ahead and plot this. Oh my gosh, that's not what I wanted. I wanted to. Okay, so now I need to kind of fix it, right? Because that's not really what I want. I don't want a column graph. I actually want a linear regression. So then I'm gonna go down to scatter plot. I just need to make sure that it's all screwed up, right? So we're gonna have to adjust our scales because of the way that we're looking at it right now. We have the flow rate, we have flow rate being one of the data points. Well, we don't want the flow rate to be one of the data points. The flow rate is going to be our y-axis, x-axis, and then the meters is going to be our y-axis. Okay, so my x-axis, I'm going to add an x-axis. So I want my flow rate to be my x-axis, right? And then my series or my y-axis, I want to remove the flow rate. So I'm going to go over here and I'm going to remove just that one. So then I'm going to go to custom. Going to go down to series. And so I have the option of applying it to all of these series, or I could just apply it to one of them. Apply it to all of them. So I'm going to add a trend line. I'm going to make it linear. I'm going to use equations, and I'm going to show R values. So you guys see, I basically did all three graphs on one, all three series on one graph, and it provides me the equation for each of the different lines. Of course, I'm going to change this label because it's all screwed up. Okay, questions? Not too bad. Anybody having trouble?
On the y-axis, edit that one and
Yes.
place that one.
Okay, so to edit that one, it's under setup. And I actually did edit the y-axis. The y-axis is just these values here, right? So I said the x-axis is going to be my flow rate. Okay, and the y-axis are going to be the distance. So if I wanted to put the units on it, distance. So then I would go to customize. I go chart. And my vertical axis is going to be distance in meters. Then I would put my x-axis on 2. So again, I go to customize chart. Say flow rate. Spell. Meters per second. Okay. Any questions? Are you using Excel? It works the same.
This is on.
Got it? This is millimeters. Okay, piece of cake. Okay. I like this class. You guys are helping each other. Makes my life so much easier. I get to sit up here and look pretty like I told you I was gonna do, right? So what is the next part?
Go to the next graph or
Okay, so let's go to the next graph. So, no, the next part is, let's do the standard deviation. Okay, so we have those grades, right? Copy, and then I probably have to re-enter it. You guys want to do it by hand? You want to calculate the standard deviation by hand? Oh, you don't? Alright, you guys are so fun.
Sheets does it.
Yes, it does. Yeah, unfortunately, we don't have a nice little table.
let's do.
Okay, so we want to calculate the sum of all of the grades. We just write sum, and then label the sum,
The right equal sum. or just
equal sum, and then it'll highlight everything that you, or you could just select the box that you want. Okay, so it calculates the sum of all of them. If I wanted to calculate the average, so I got the average. So then here, right above it, I'm going to write equal, and then I'm going to put average. You see, it already does it for me. All I have to do is hit tab. And so now I have the average of my grades. You just hit tab and it'll automatically fill it in. Or you could just select the ones that you want and then hit them. So if I want the standard deviation, I'm going to put equal, And then you already see, it already did standard D, because I already said I want standard D. Right, and then all I have to do is hit tab. And then I've calculated my standard deviation.
What did I say? Oh, it's seven.
Okay, so now I have my standard deviation. All you do is, all I end up doing, I put equal. And then as soon as I hit equal, next, since I type standard deviation, it recognizes that I want to put my standard deviation here. So it automatically puts in, and then all I have to do is hit tab and it will automatically put it in. If not, I just write STD EV, standard deviation.
Okay, Henry, I feel your pain that you used to have to do this by hand a long time ago.
Oh, yeah.
I can only imagine that.
Grades, yeah. I TA'd a class. It was a long time ago, we'll put it like that. When I was in grad school, and we had to do all of this, right? The instructors didn't do it, the TAU took care of all of it. And we had a class, I had a class of 250 students. I had 5 sections, right? So they would meet different days a week. It was painful.
Just see numbers by the end of it, huh?
Yeah, so I was like, I didn't want to grade up a curve after that. I'm like, I'm never grading a curve. Forget that crap. Because that's what you use standard deviation if you're going to use a curve. Yeah, and then now I'm like, man, you know. And the bad part was that this was available when I was in school too, but we didn't know about it, right? Nobody's taught us. I actually learned this when I was in grad school, towards the end part of grad school, when I started really doing data analysis and stuff. So
It took a while to see that it was gonna be implemented in school. That's sad, honestly.
that is,
Oh,
yeah, because it could have saved me so much time.
Now we're ahead.
Yeah, I learned a lot in my engineering classes, but I didn't think that it could be applied the same way. You know, so I didn't think about it, right? It's like when you go through, often we'll go through and take a class and you're like, oh, I gotta take this class to check out the box, right? And you don't think about how you use it. So I had all these tools that I never used until I'm like, oh my God, I can't get
Yeah,
together.
I see it, though, I see it.
Or do.
Okay, anybody having problems? Pretty straightforward. So then you can use this data to sit there and fill in the chart. I'm gonna let you guys play with that yourself, because then you're gonna use the standard deviation to calculate the grade. So make sure you read the instructions, because I want you guys to read the instructions. Okay. So it should be on the next page. So you calculate the average, you calculate the standard deviations, and now you need to put that range. So you kind of read the instructions that tells you that process. Okay. So let me see, what is the, I'm gonna see if you need me to guide you to that last. Okay, so the next one is using the skills that you've learned and the fact that you can actually draw the data points. I want you guys to determine the slope and the y-intercept of the equation above. Right? Using the data, like by graphing the data. Okay. Sorry.
I'll sell you a Red Bull.
You sell me a Red Bull? How much? If you're gonna get take money off $1, that you pay more for the Red Bull at the store.
Oh, it's on water, so it's take.
Oh, so it's free, okay. No, actually, I have a stash, 60% apple monster, that is like my emergency monster, it's so bad, although I should have used it on Monday, man, I really should use it. You know, being here till 10 o'clock at night, and then,
Oh.
I get in, like this morning, I got in at 7:50, right? So I'm here from 7:50 in the morning, which means that I have to get up, I live in Hanford,
Oh.
I gotta get pretty, you know, it takes me a while to put those, you know, beautiful face.
Yeah, that's a solid like 16, 18-hour day, huh?
Yeah.
For sure. Problem solved.
I really see my car later than-
I thought about it. No, or sleeping in underneath my office on the floor. I thought about that too. And I have. I'm like, yeah, I should get a sleeping bag. But then I see the cockroaches that are about that big that are outside. I'm like, yeah, I'm gonna have a heart attack.
There was a grasshopper on the urinal.
Really?
Yeah, I was like, what's going on?
You're like, he had to go pee, right? He's like, dude, this is my stall.
That's my school. Better jump at me.
So do you guys feel that you're learning computer techniques? Kevin, you have that look. Are you struggling? Let me come over there. Let me see what you're doing. So did everybody get the next one graphed? That is, yes, why you're weak, right?
So give me that one right there.
Help us
That's so
decide what
below
the,
the standard deviation what we're doing. So I opened up a whole new sheet. I did on a new sheet.
I don't know how this is. Okay.
Yeah, he sent you. No.
Yeah,
He sent- That one is the next one. That one's
That's up below the standard deviation.
Okay, they want.
He was on the lab 3. That one you gave me on that day. I know how papers.
Okay.
Yeah, you just said.
Yeah, just straight graph.
Oh, yeah. That's what you said, right? Oh, okay.
Let me use a regular graph.
Oh,
Is it?
City one.
The writing stuff. I mean, the writing stuff is very-
Oh, sure. I went with Luke myself. Next slide.
Bigger head.
He was.
They're not like, you will come across it eventually.
I hated it.
Looks solid on the side. And then I already set our X and our Y for it too.
Especially.
Is it on the bottom of the series? Is that on the bottom of the series?
Just graph those.
Yeah, graph it and then also go to the customized section on the edit. And then go to the R squared and put show R squared. And then above the show R squared, it has a little drop down menu right there and click the code.
So what we did with that.
Okay, so you go down.
Yeah, basically.
Go down series.
Yeah, you put the trend line too.
Yeah. Good. Chart.
So use. Oh, use graph. Yeah, no, that's right, that's right. Use. It's a perfect fit, but that is not. Because you're, oh, wait a minute, no, you're fine, because we're at 2, right? We're not at 0.
Yeah.
Yeah, okay. So you're fine.
Okay.
That was just. Now it makes sense.
I'm asking just like to see if it wants a scatter plot or a line chart.
And so if you could change the scale, I think if you double click on the, actually, let's scroll down a little bit. Let's go the vertical. So you can change your minimum value and your maximum value. Right? Okay, so let's put our minimum value is at 0, maximum value is 100.
At 100?
100, yep. Okay, now do the same thing with the x-axis. So put your minimum value at 0 and then your maximum value at 5. Okay. And so you guys can actually see it hit the 0. Yeah. Right.
And do you want a scatter plot or a linear graph?
Scatter plot. Yeah. So normally when you're doing, let's say an x and a y value, it's scatter plot. But you can get away with using a linear graph. Linear graph, you can. But usually a linear graph is like if you're not looking so much like the form of line, but you're just looking at the trend. Yeah. Yeah, if you're looking at how much money Dr. Henry makes, so that flat line, right? Instead of going up. So, or this initially, industry, education, you know. Okay. Questions? Everybody's feeling comfortable? You think you can answer the rest of them, right? I think not a problem. Okay, so let's talk about the lab real quick. So what I want you guys to do, you need to gear up. I need you to gear up because you're going to be handling chemicals. So if you take a look at the lab, it's basically you have like a little page answering that question for part 1. You guys can do that pretty much at any point. I also, for part 2, I have 3 chemicals, right? I want you to come up here. I want you to take a look at it, write down the chemical name. Right?
It's on lab 4, correct?
This is lab 4, yeah. Yeah, everybody has lab 4? Okay. So write down the chemical name, and then I want you to come up here with your gloves or goggles and your nice little coat. You're gonna work around, and you'll notice that it has either the GHS, what is the GHS again?
The hazard.
Global harmonizing system. Okay, or it's gonna have the NPFA. National, okay, there you go. There you go. Good job, okay? So it's gonna have one or the other, or it may have both. And you're gonna use that to sit there and tell me about the chemical, right? Tell me about its habits, okay? And the other thing that you're gonna do on your own, you're gonna find an STS for each of those chemicals, right? And you're gonna figure out how to handle it. And by using that, so you wanna highlight it, you're gonna put that in your lab report, cut it out. Paste it in there, and you're also going to tell me how to store it. Last thing that you need to do is give me the chemical formula for those chemicals. Okay. So the 3 chemicals, right here, right here, right here. Right. Best part, I have to pick this to fire. Yeah, they don't have any chemicals.
Oh, yeah.
Where are you gonna store them now?
I have to bring it back here. Right? And I gotta do it early enough so that they don't bad things don't happen. So good.
Are we gonna be starting this off?
I may
today?
get a new cart in school. What was that?
Are you gonna start this off today or for next Wednesday?
No, this is for today.
Okay.
It'll take you 5 minutes
Yeah.
at most.
And we're all, everyone in the class are looking at those 3?
Yeah, so suit up, gear up, glove up. Because as much as these bottles are supposed to protect you, a lot of times you spill stuff on them. And you can actually smell some of the aroma. Yes. And just do me a favor, do not open. Actually, don't open any of them. Don't open any of them, specifically the sodium. Do not open.
Organic. Because I'm using it.
Okay.
It's 'cause it's-
Okay, so you're using the standard deviation
Yeah.
to determine the range of the
Everything else I
so the average. So the average.
I do everything right.
Right. So then, and the standard deviation tells you.
Yeah. At least I hope I did.
It actually tells you how you should do. So you're using what to determine the range of that grade. You're the teacher now. This is why we're-
Oh, true.
What's that?
The trend line.
After.
That's clear.
You-
So
you
I
need
did-
help?
So when
Yes,
you
I do.
do the horizontal axis. You want to put it to 0 and then max 0 and 5. And 5.
That's what I understand.
And then for the
Okay, because I'm
vertical
using it.
axis,
So right, it's different. I don't know
I'm
what
gonna put it
they're
0
using.
to 100.
Okay, so you want to add the trend lines? Okay, so.
You
So
show.
here. Okay, and then you want to actually get some more options. And then you scroll down.
There's the other
So display chart.
I'm on the
Display.
It's not supposed to like.
Extend, so Excel doesn't do that. It's like, right, so it'll just draw. to- You don't have to worry about it because in your case, you can't see it.
And I tried logging in over here. But
Okay. You wanna. Oh, this is not true. So it's not allowed. So, actually, you can.
I was coming out like.
Case.
I tried signing in, right?
Uh-huh. So do you have a Google account? Do you have your own Google account?
Personal one, yes.
Yeah, so use your personal one. Don't use your, because school-wise, it doesn't. We're not Google based. We're actually, I should say, office based. So you guys actually have access to the office. But most of you guys have Google accounts. Forget your password.
It's because I have like 3 emails, one's for spam, one's for personal, and one's for work.
Okay. So do you remember your spam one or do you remember?
I have like 10.
Jeez.
I have to get the free trial somehow.
Oh, okay, I see what you guys are about. See, I like that
I
free.
have 1 or 2 from like all the way in middle school that I use for spam and.
So see if you can remember one of them.
Want to sign up for, but don't want emails from.
Uh,
And then I have like a personal but not professional one,
Okay,
professional one, super personal one, spam only. Like,
there you
you
go.
gotta delegate your emails these days. So how do I get finished with that?
Let's, we'll go and grab you. It's not there?
Or should that wait?
Okay. No, no, it shouldn't. What size were you? It's just totally missing the hanger out. I added. Down there. We can see what it was. So, okay, so. other than the extra large.
Bro, what?
I do.
Some over here.
Oh, my, big lie. There's only one, man. There was one in that one too.
Alright, let me go check the inventory in the back, bro.
I would have had a pair.
I checked the inventory. It's just extra large, right?
Yeah. I think that's all we're missing.
That's a home.
Yeah, just a wash.
Yes, no, we haven't. Actually, you should be able to just push on it.
That's the thing.
Let me see how this fits on you. Well, actually, we'll go to Brendan next time.
Why is it turning into a Google Doc? You just take a picture.
You do lab coat, should be-
That goes paper.
Maybe not.
Try this one. This one.
If you can't figure it, then I'll just send you.
You want my email, you might.
I don't know if it's
It's a
supposed to
little-
like.
Huh?
Yeah, but you can cut it. This part. we can't.
Well, if you.
It's a little bit. Maybe a lot. Yeah. That's an extra. So let's see about this. Okay, let me go and run and grab you a large.
Hey, you only have one, right?
Yeah.
Here's the other one.
Yeah, I think.
And,
Yeah. Everyone's like, just identifying those things.
yeah, just identifying things you're supposed to
City,
figure out
data.
how to store them.
transfer.
Other stuff. I don't have that one. Yes.
I'll be right here.
Yeah.
Wait, we just choose one, right?
Yeah. One of the.
Oh, so you-
It's the pictures you're gonna find. I don't know. But I don't know which ones yet. I think so though, yeah. We should have our pictures. Sure.
Why don't you come down here? Why don't you take pictures?
Yeah, I'm gonna take pictures of y'all, like, send it to the
You're
group chat y'all
still
want.
exposed to.
Yeah, yeah, yeah.
I got y'all.
So I just put this up.
For real.
Nah, you have to do the whole thing with that on. Now it's like this.
So you just said,
That'll be in that science one.
crazy.
Well, he's sending it, right?
Yeah, he said.
I know, right? And
I
then.
thought I was gonna go like put shade and fucking, there's some shit. No, I'm just gonna write shit on the paper.
Too, but it's like identical.
Can't open into that.
I think I opened mine.
So they're not
I did, forgot. I
What
opened
did you
my
pick it
car.
up?
I think so.
You would have already known my. As long as it doesn't open.
I'll put it right next to your desk.
That shit will be put it like around your chair or something.
Struggle to find drugs and everything.
No, for real.
I appreciate it.
So that's it, right?
I guess, right? Which is 30%.
So. I can turn this back.
Oh, yeah.
Um, it's time to look up the stuff. Yes.
They're pretty good.
Are we allowed to
Sorry.
take it off?
You are
Or we
good.
can make it?
Yeah, you're good.
That's it.
Pretty much.
Maybe later, but I think right now it's- Oh, our research day, you know?
You know what, just because I want to keep it on. I'm gonna just leave it.
Yeah, me too.
I don't feel I want you back after I walk there.
Also, we
Might as well
don't
make it where we want.
Yeah.
Hey, what if that a cut or a hole in it? You know what I'm saying? Then you would have been asking for it.
Yeah, but I didn't go near.
Hey, you can still get it.
Unless you
But just for the, like,
Yeah, no.
Yeah, I prefer type, because I have third grade handwriting, and I struggle to read my own after I write something. So. So now this, I think we're gonna make this. We gotta. Next up. Remember the paper current type treatment?
I know.
Yeah, it's supposed to be.
It's right here. I'm gonna choose one of those chemicals.
Struggle. It's a nice
Oh,
photo.
Kathleen, I'm gonna let you go.